Welcome to the solutions to the Regents Physics problem set, problems number 11, 12, and 13. Problem number 11 was already discussed in the video lesson on Newton's second law and friction. So you'll see the same answer there. So we're not going to spend time in this video going over this again. So we're going to go to number 12. Let's start by reading the problem and labeling the information. We have a force of 40 newtons, so we underline that and label it F. Accelerates, you could argue that that could be underlined and labeled with an A. 5 kilogram mass, so because of kilograms we label it M, at 6 meters per second squared, and there's your value of acceleration, so that's been labeled A, along a horizontal surface. How large is the frictional force? And since it's moving, we identify that to be the force of kinetic friction. And B, what is the coefficient of kinetic friction? And we'd label that mu k. The next thing we would do after reading the problem and labeling the information is we would draw a free body diagram. We have the force of 40 newtons to the right. We have the kinetic friction opposing that motion to the left. We have the weight down and the normal force up. I've also included a motion arrow not attached to the diagram itself above it here, saying that it's accelerating at 6 meters per second squared to the right, and I've indicated and remind myself that to the right is positive. For A, how large is the frictional force? We start with Newton's second law statement, sigma F equals ma. The next question we ask is this object accelerating? And the answer is yes. So we leave it just as is. Our next step, we summate the forces. We have the forward force F minus the kinetic friction backwards, so F minus Fk equals ma. We now substitute all the information we have available to us. We know the force is 40 newtons. We know the mass is 5 kilograms, and the acceleration is 6 meters per second squared. We do the algebra and solve for Fk to be 10 newtons. To 2 digits, because of the mass and the acceleration, we would need a decimal point after our 0. There's your answer to A. B, what is the coefficient of kinetic friction? We now use the definition of kinetic friction, which is Fk equals mu k Fn. So Fk equals mu k times, well, in this problem again we see it's not accelerating vertically, and these are the only two forces acting on it. So again, here in green we have our summation vertically, summation in the y direction here, showing that Fn equals mg. I will say that you don't need to do this every single time, as long as you remember that on a flat horizontal surface with no other forces or components acting vertically, that these two are equal to each other. So you see in the next step here, substituted Fk equals mu k times mg. We know our frictional force is 10 newtons from our answer to A. We know the mass is 5 kilograms, and the acceleration due to gravity is 9.81 meters per second squared. We do the math in the algebra, and we get mu k equal to 0.20. All right, let's go on to number 13. Let's start again by reading the problem. 225 kilogram crate. We know that it's the mass due to the units. It is pushed horizontally with a force of 710 newtons. So we underline that and label it with an F. If the coefficient of kinetic friction is 0.200, so we underline that and label it mu k, calculate the acceleration of the crate. So we underline the word acceleration and label it A. That's what we're trying to find. Next step, we draw a free body diagram. We have our weight down, normal force up, our forward force of 710 newtons, our backward friction of kinetic friction labeled Fk, and above this I have a motion arrow reminding us that the object is accelerating, and that direction of motion is positive. Next, we start with Newton's second law expression, sigma F equals ma. Is the object accelerating? Answer is yes, that's what we're trying to find. So we leave the equation as is. Next, we summate the forces in that plane in which it's accelerating, which is horizontally. We have the forward force F, which is positive, and the backwards kinetic friction, which is negative, so it would be F minus Fk equals ma. We're now going to take a shortcut here, and we're going to say, okay, well, what's the formula for kinetic friction, and include that in our equation. And we remember that Fk equals mu k Fn. So our equation here in the next step becomes F minus mu k Fn equals ma. We then also remember, since this is on a horizontal surface, that the normal force and weight are equal to each other. And so our equation evolves to F minus mu k mg, replacing Fn, equals ma. We now go ahead and substitute all our known variables. We know that the force is 710 newtons. We know the coefficient is 0.200. The mass is 225. Acceleration due to gravity 9.81 meters per second squared. And again, our mass is 225 kilograms times a, which is what we're solving for. We do the math and perform the algebra, and we find that a is equal to 1.19 meters per second squared. I hope this has been helpful in understanding how to do these three problems using Newton's second law, and you'll have more practice on this as we do 14 and 15 in class together.